Galileo Galilei is one of the greatest scientists in human history, a man who played a pivotal role in changing our understanding of the universe. At a time when science was governed by traditional concepts and ancient astronomical interpretations, Galileo opened new doors for scientific discoveries that led to the scientific revolution in Europe. Galileo is considered the founding father of many principles that shaped modern science, including the experimental method and the use of mathematics as a tool to understand natural phenomena. Throughout his life, Galileo challenged many prevailing concepts in astronomy and physics, and he died at a time when his scientific voice was highly controversial, particularly in the face of the Catholic Church, which sought to preserve the old theories about the universe. However, Galileo left behind a tremendous scientific legacy and paved the way for many discoveries that shaped modern science. Galileo Galilei was born on February 15, 1564, in the Italian city of Pisa. He grew up in a middle-class family, with his father, Vincenzo Galilei, a musicologist and thinker interested in new ideas. Although Galileo was surrounded by an intellectual and scientific climate, he initially studied medicine at the University of Pisa, based on his father's wish that he become a successful doctor. However, Galileo, who had a passion for mathematics and natural philosophy, today's physics, was not comfortable studying medicine and eventually decided to focus on mathematics. In 1589, he began teaching mathematics at the University of Pisa, a position from which he began his distinguished scientific career. As a young man, Galileo was influenced by many philosophers and scientists who preceded him, such as Aristotle and Pittacus, whose writings had a significant impact on his thinking in the fields of motion and physics. At that time, many old ideas, such as those proposed by Aristotle regarding motion and physics, were considered the foundation of science. However, Galileo began to question these theories, believing that science should be based on experiment and observation, not just abstract philosophy. Galileo was also influenced by the rising mathematical thought of the time, especially through the works of Italian scientists such as Fermat and Descartes. This influence drove Galileo to develop new scientific foundations based on evidence and experimentation. In 1609, Galileo began using the telescope to study the sky, a device that had already been invented by some Dutch inventors but had not yet been used in astronomy. Galileo improved the telescope's design, allowing him to magnify celestial objects more accurately and in greater detail. With the improved telescope, Galileo could see the sky more clearly than ever before. He used it to study Jupiter, leading to the discovery of its 4 moons. These 4 moons, which Galileo named Galilean moons, were Io, Europa, Ganymede, and Callisto. This discovery was crucial because it showed that celestial bodies could orbit another planet besides Earth, providing irrefutable evidence against the ancient geocentric model that placed Earth at the center of the universe. Copernicus's theories had begun to spread throughout Europe, but they were not widely accepted in scientific and religious circles. Copernicus proposed that the Sun was the center of the solar system, and that the Earth and other planets revolved around it. Galileo was a staunch supporter of this theory, and attempted to bolster it with his astronomical observations using the telescope. In 1610, Galileo published a book titled Letter to the Cardinal, in which he presented evidence supporting the Copernican theory. In this book, he also pointed out that the moons he discovered around Jupiter orbited it, indicating that not everything in the sky revolved around Earth. However, this book sparked opposition from the Catholic Church, which rejected the idea that the Sun was at the center, as it contradicted the religious view of the universe at the time. As Galileo's fame grew and he announced his support for Copernicus's theory, the conflict between him and the Catholic Church escalated. At the time, the Church held significant control over intellectual and religious life in Europe, promoting the traditional idea that Earth was the center of the universe. the Ptolemaic theory. Galileo, by supporting the heliocentric theory, was questioning this doctrine and presenting new ideas that clashed with traditional religious concepts. In 1632, Galileo published his famous book, Dialogue Concerning the Two Chief World Systems, which supported Copernicus's theory. The book featured a debate between characters holding different views of the universe, and Galileo included a caricature of the Church. This book angered the Church, leading to Galileo's trial in 1633 on charges of heresy for supporting Copernican ideas. During the trial, Galileo was forced to recant his views publicly and admit that Earth was stationary in the universe and that the Sun revolved around it. As a result, he was sentenced to house arrest for the remainder of his life. Despite his trial, Galileo continued to work. In the final years of his life, he wrote many works that had a profound impact on the development of science. His contributions to mathematics, physics, and astronomy laid the foundations for many later scientists, including Isaac Newton. Galileo was also one of the first to use the experimental method in science, believing that science should rely on careful observation and experimentation rather than abstract philosophy. Galileo Galilei is a central figure in the history of science. His work transformed astronomy and physics into fields based on experimentation and mathematical observation. Despite the struggles he faced in his lifetime, Galileo is still considered one of the greatest minds that influenced the scientific trajectory of humanity. Don't forget to subscribe to the channel. Thank you for watching. See you in more stories.